Hello everyone, welcome back to another GIS Mathematics lecture video. And in this lecture video I want to go through another example, and I want to walk through a slightly more complicated example of matrix multiplication. And I want to show you the internal method, and I'm going to write it out explicitly. The internal method that I use to keep myself organized when doing matrix multiplication on larger matrices. So let's go ahead and look at an example of two matrices. So we'll have A, which is 2, 6, 6, 2, 5, -1. And then let's go ahead and do B, which is going to be -4, 5, 0, -4, 4, and -4 again. Okay, so this is A and B. So let's go ahead and first ask ourselves, what is A times B? Okay. So the first thing I do whenever I see a matrix multiplication problem is I look at the dimensions. So A in this case has 3 rows and 2 columns. All right, B in this case has 2 rows and 3 columns. And so anytime we're ever doing matrix multiplication, the first thing you have to do is line up your dimensions like this and make sure that the inner dimensions match, right? Does 2 match 2, which it does. So we're good to proceed, right? We've talked about this before. The other thing we do then is we look at the outer dimensions and we say, okay, well, this is a 3. So we know that A times B is going to have 3 rows. We see this 3 here, and we say, okay, it's also going to have 3 columns. So that means that A times B is going to be a 3 by 3 matrix. Okay? So this is how I keep myself straight. And maybe I should have shown this in the beginning. But the way that I keep myself straight is I assume that each element, right, is an unknown. We don't know what it is yet. And so what I do is I fill up all these spaces in my brain. Again, I do this internally. I'm writing it down to show you, right? You don't have to write this out. This is what I do. Right, I fill all of these spots, right? All 9 elements, right? We have a 3 by 3 matrix, 3 rows, 3 columns with X's. And then what I do is I put a little subscript for where it is in the matrix, right? So this X here is in the first row, so it gets a 1. It's also in the first column, so it gets a 1 there. Right, this matrix is in the first row still, but now it's in the second column, so it gets a 2 there. Right. Again, I want to take a step back. Right, this is 1, 1 because it's in the first row. It's also in the first column. Right, this one gets a 1, 2 because it's in the first row, but it's in the second column. So similarly, this one here is going to get a 2, 1 because it's in the second row, first column. Okay, and so we can finish that out. This would be 1, 3. This would be 2, 2. This would be 2, 3, 3, 1, 3, 2, and 3, 3. All right, so all I've done is I've given myself this matrix here with unknown x's because we don't know what they are, with subscripts for each row and column. Okay, so this is how I organize myself. Now let me show you why this works. So if we solve for x1, 1, right, all I have to do now is look at the subscripts. So x1, 1 means take the first row of the first matrix, right? So let me highlight this in yellow. Right, this means take the first row of the first matrix. So that's going to be this number right here. Times the first column, right? The first column of the second matrix. That's going to be this number right here. All right, so if you think about what we've done here, we've just isolated a row vector and a column vector. And we know how to do that, right? That's just saying, right, 2 times -4, right? That's the first element in this row times the first element in this column, plus 6 times -4. Right? That's the second element in this row times the second element in this column. And so if you do that, right, you get -8 here and you get -24 here. You add those up, you get -32. Right? And so if we, since I'm going to be putting a whole bunch of examples over here, right, if we go down, right, we now know that the first element is going to be -32. Okay, so then we just kind of progress along just like this, right? So we have x1, 2, right? x1, 2 means the first row of the first matrix, right? So that's again going to be this. So we know we're going to be taking the 2 and the 6, right, from the first row of the first matrix. And then this 2 here, right, this means take the second column of the second matrix, right? So if we do this, that's going to be this matrix right here. All right, so we're going to take the 5 and the 4, right? And so if we do the math, right, that's 10 and that's 24, and we get 34. And so again, right, that's going to be x1, 2. So that's the first row, second column. That's going to be 34. Right. So we can continue doing this. I'm not going to sort of draw out the dashed lines anymore. I'm just going to kind of move through. So if you seem confused as to where numbers get pulled from, I encourage you to pause the video and think logically about what these subscripts mean, so you can follow along. Right, so x1, 3 is going to pull the first row from the first matrix. So again, that's going to be that 2 and that 6. It's going to pull the third column from the second matrix, which is going to be that 0 and that -4. Okay, so if we do the math here, that's 0, that's -24. So we're going to get -24, which is going to go down here into that column. Okay. So I'm going to go ahead and I'm just going to progress through this. All right, so 2, 1, it's going to be 6, 2, -4, -4. All right, x2, 2 is going to be pulling the second row, so that's that 6, 2. And then we're going to be pulling the second column. All right, we're going to be pulling the second row. We're going to be pulling the third column. So that's going to be 0 plus -8. Right, I'm going to slide down just a little. Oh, maybe I can't. I'm going to slide over just a little bit because we're running a little bit out of room here. All right, so x3, 3. Right, so now we're going to be pulling the third row from the first matrix and the third column from the second matrix. So this is actually going to be this corner here. So we're going to pull 5 times 0 plus -1 times -4. That's 0 and 4 gives us 4. Right, x3 comma 1. So this is going to be the lower right, or sorry, lower left. Again, we're taking the 5 and the negative 1. We're multiplying negative 4 and negative 4. So that's going to be negative 20 plus 4. It's going to give us negative 16. And then finally, x3, 2. So this is the third row from the first matrix and the second column from the second matrix. So this is, again, it's going to be that 5 and that negative 1. And then we're pulling the second column, which is 5 and 4. And that's going to give us 25 plus negative 4. It's going to be 21. All right. So hopefully that makes sense. Hopefully this method helps you organize yourself. I find these subscripts, again, I do this internally, but if you need to write them out, it's a really good way to keep yourself organized. In the next video, because this is getting a little long, I want to go through what b times a would be and why it changes both the dimensions and also the way that which rows and columns we access. So hopefully this makes sense and is helpful. And if you have any questions, please reach out. Thank you.